Hello students, how are you doing? This is the last lecture of your electricity chapter, and in this lecture we will solve few more numericals. Before solving the numericals, I want to share you something that do download our Nakatra app for the live classes, test, doubt sessions, and even the recorded classes are also available. So the link is given in the description box. Okay, now let's start. See question number 1. Several electric bulbs designed to be used on a 220-volt electric supply line are rated 10 watt. How many lamps can be connected in parallel with each other across the two wires of 220-volt line if the maximum allowable current is 5 ampere? Now write it down. What are the given values? The potential difference V is given 220 volt. Maximum current I max 5 ampere and the power of one bulb P1 10 equal to 10 watt. So we have to find out the number of bulbs to be connected in parallel. Here we will consider X as the number of bulbs. The formula we will use power formula, that is power equal to V square by R, Ohm's law V equal to IR, and 1 by R equal to 1 by R1 into X. Now let's solve. The resistance R1 of the bulb is given by the expression P1 equal to V square by R1. So we will rearrange the formula and we will find out the value for R. Therefore R1 equal to 220 square by 10, we will get 4840 ohm and mark it as equation number 1. Now according to Ohm's law, V equal to IR. Here R, it is the total resistance of the circuit for X number of electric bulbs. Alright, so R equal to V by I. V is 220 and I is 5 ampere, so we will get 44 ohm and mark this also as equation number 2. Now 1 by R equal to 1 by R1 into X. From here we will find out the value X. And we will put here the values from equation 1 and 2. So X equal to R1 by R. For R1 we know that it is 4840 and for R it is 44. So after calculating it we will get 110. So the answer is 110 electric bulbs are connected in parallel. Easy? Alright. Move to question number 2. A copper wire has a diameter of 0.5 mm and a resistivity of 1.6 into 10 to the power minus 8 ohm meter. So this is a copper wire where the resistance is given 10 ohm, diameter is given 0.5 mm and rho is 1.6 into 10 to the power minus 8 ohm meter. Alright, now write what are the given values. So here since diameter is given, so we will find out the radius and we will get 0.25 into 10 to the power minus 3 meter. We have converted it into meter from millimeter. So what we have to find out? For A we have to find out the length L and for B the resistance change if the diameter is double. So we have to find out how much the resistance change if the diameter is double. Alright, so now let's see the formula. Here we will use this resistance equal to rho into L by A. We know that A is area and its formula is pi R square. Alright guys, start solving it. R equal to rho into L by A. So rho equal to R into A by L. Therefore L equal to R into pi R square by rho. Now put the values. For resistance R it is 10 into pi is 3.14 and we know that the radius is 0.25 into 10 to the power minus 3 whole square. Okay, and what is the resistivity? 1.6 into 10 to the power minus 8. So after calculating it we will get the value for length. Guys, start doing this calculation by yourself. Definitely I am helping you, but you have to try it by yourself, okay? So after doing the calculation, we will get the length L equal to 122.65 meter. Okay, now we will see for B. See, we know that the area is proportional to the square of the diameter. Therefore, the resistance is inversely proportional to the square of the diameter of the conductor. Okay, so the resistance gets decreased as the diameter is increased. So, when the diameter of the wire is doubled, then its resistance will become 1/4. Done? Okay, so now see question number 3. Compare the power used in the 2 ohm resistor in each of the following circuits. 1. A 6 volt battery in series with 1 ohm and 2 ohm resistors, and a 4 volt battery in parallel with 12 ohm and 2 ohm resistors. Alright, so see here in this circuit, the R1 and R2 are connected in series, where 6 volt battery has been connected and current I is flowing. So we have to find out the power P1. Now see in the next circuit where a 4 volt battery has been connected and it is in parallel connection, where the R1 and R3 are connected in parallel. Here also current I is flowing and we have to find out the power P2. Now current in both the circuit is I, so the resistance is 2 ohm, hence by using the formula P equal to I square into R, and the power used in both cases will be the same. Okay, now write what are the given values for R1, R2, R3 and the potential difference V1 and V2. So these are the given values. Now what we have to find out? We have to find out the power P1 and power P2. The formula we will use, resistances are connected in series, V1 equal to I into Rs, Ohm's law, and the power equal to I square into R1. And we have to for power P2 equal to V2 square by R1. Now start solving it. For the case 1, 1 ohm and 2 ohm resistors are connected in series. So write the series formula. Now put the values. We will get Rs equal to 3 ohm. Therefore V1 equal to I into Rs. Okay, we know that V1 is 6 volt, and for I it is we have to find out, okay, the I, and Rs it is 3 ohm. Therefore the current I is 2 ampere. Now you have to find out the power P1. So power 1 equal to I square into R1. Put the values, we will get 10 watt. Okay, now for the case 2, 12 ohm and 2 ohm resistors are connected in parallel. Now see, in parallel combination, potential difference remains same. Alright, so here the potential difference across 2 ohm resistor will be 2 volt only. Now we can write it directly, P2 equal to V2 square by R1, and we will get a P2 equal to 4 square by 2, that is power 2 equal to 8 watt. Is that clear, students? Okay.
कोई भी सपना साकार करने के लिए सबसे जरूरी है सही कोच का होना। चुनिए नक्षत्र को और करें अपनी 4th to 12th classes and government preparation का सपना साकार। Download the app now.
Now say question number 4. Calculate the effective resistance between P and Q. So this is a circuit where 5 resistors of resistances are connected. So see here we have to find out the effective resistance between P and Q. Here the 7 ohm and 3 ohm are in series connections. Okay. Similarly 6 ohm and 4 ohm are in series connection. So for triangle PAQ we will find out the resistance that are in series connection. We will add 7 ohm plus 3 ohm, we will get 10 ohm. Similarly for the triangle PBQ we will add this 6 ohm and 4 ohm, we will get 10 ohm. Now 10 ohm, 1 ohm and 10 ohm resistances are in parallel between P and Q. Alright, so now we will use the formula for resistances in parallel. We know that 1 by R equal to 1 by 10 plus 1 by 1 plus 1 by 10. After calculating it, we will get R equal to 5 by 6 ohm. Is that clear? Alright, now move to question number 5, the last question. 5 resistors are connected as shown in the figure. See the figure where 5 resistors are connected. Find the ammeter reading when the circuit is closed. Okay, this question is similar to question number 4 only. Now see here, we have to find out first the effective resistance between B and D, between the point B and D. So see, the 3 ohm and 3 ohm are in series combination, and this 3 ohm is parallel to these two combinations. So now RS equal to, we will add these two resistances as they are in series combination, so we'll get 6 ohm. Now when it is in parallel, as I told you, this connection is parallel to these combinations, so 1 by Rp equal to 1 by Rs plus 1 by 3. For 1 by Rs it is 1 by 6 plus 1 by 3 equal to 3 by 6. Therefore the Rp is 2 ohm. Here the equivalent resistance will become 2 ohm. Alright. Now see, between point A and E, the effective resistance between point A and E. So this 0.5 ohm and 0.5 ohm are in series, and this will become your 2 ohm. Therefore we will add all the three resistances. So Rs equal to 0.5 plus 2 plus 0.5, we will get 3 ohm. Therefore current I is V by R equal to 3 by 3. That is the ammeter reading equal to 1 ampere. Alright. So this is all about the electricity chapter, students. Thank you.